Hey guys, welcome to Code Streak Daily. In today's video, we are going to solve the problem of the day of Geeks for Geeks, and the date is 15th of October. So here we have a problem sub-array range with given sum, and the difficulty level is medium. Now let's see the problem description here. So here we have an unsorted array of integers, and we have a target. We have to determine the number of sub-arrays whose elements sum up to the target value. So that's a good question actually. So let's see, here we have an array and there are five elements here: 10, 2, -2, -20 and 10. There is a target -10. So we have to check how many possible sub arrays are there whose sum will be equal to -10. So here we have a sub array of 10, 2, -2 and -20. So 2 minus 2 will be 0, 10 minus 20 will be -10. So we have a target, and we have another subarray 2, -2, -20 and 10. So this sum will be equal to -10, and we also have another subarray -20 and 10. Okay, so therefore the count will be 3. In the second array we have 1, 4, 20, 3, 10 and 5. The target should be 33. So there will be only one possible subarray, that is 20, 3 and 10. So the count will be 1. We should be return output as 1. So here we have an expected time complexity of order of n, and the auxiliary space should be order of n. So now here in this problem, so we are using a hash maps here. Okay, now basically here we have a class solution and there is a function defined subarray sum. Here we have two parameters pass, one is array and the other is target variable. Okay, now we will initialize variables like a count, which will store the total number of subarrays whose sum will be equal to the target. Then we'll also have a current sum which keeps track of the running total or the cumulative sum as we iterate through the array. Then we also have another variable sum map, which will be a hash map or a dictionary that tracks how many times each cumulative sum has been encountered. Okay, we will start with 0 1 because an empty subarray has a cumulative sum of 0. This helps us account for subarrays that start from the first element. Okay, now here I'm initializing a variable count equals to 0. Then I have another variable current sum. This is also is initialized to 0. This keeps track of the cumulative sum, as I said. Then I have a dictionary or a hash map where I am initializing it to 0 and 1. Okay, now this keeps stores the frequency of the cumulative sum. Okay, now we initialize the sum map with 0 1 because we consider an empty subarray with sum 0 at the start. Now we have to loop for num in array. We have to add the current number to the cumulative sum. Okay, current sum will plus equals to num. Okay, we have to check if current sum minus target exists in the sum map or not. If it exists, it means that there is a subarray ending at the current index that sums to the target. Okay, so for that we have to check if current sum minus target is in sum map. So if that's the case, then we are incrementing count plus equals to sum map of current sum minus target. Okay, then we have to update the sum map with the current sum. If it already exists, we have to increment its count by 1. Otherwise, we just need to add the current sum to the map with an initial count of 1. Okay, so for that, if current sum in sum map, then what we have to do? Sum map of current sum, we have to increment it with 1. Else sum map of current sum will be equal to 1. Okay, now we have to return the count. Okay, uh, what we are doing actually here in this, we are iterating over the array using a for loop. In each iteration we add the current element to the current sum, which represents the cumulative sum of elements up to the current position of the array. Then we are checking for the target subarray, right? So the key insight here is to check if current sum minus target exist in sum map or not. Why? If current sum minus target is present, it means there is a previous cumulative sum that when subtracted from current sum gives us exactly the target value. In other words, what will say the elements between previous point and the current element form a subarray whose sum will be equal to the target. Okay, if such a cumulative sum exists, we add its frequency in sum map to count. This is because there could be multiple subarrays that sum to the target, and after checking for the target subarray we have to update the sum map with the current value of current sum. If this cumulative sum has already been seen, we increment its count in the map by 1. If not, we add it with the initial count of 1. This ensures that for the next element in the array we correctly track how many times each cumulative sum has been occurred. Okay, after finishing the iteration through the array we will return the count which holds the number of subarrays that sums to the target value. Now let's see our code works or not. Let me compile and run. Okay, there is some runtime error. Current sum, okay. What's the line actually? Line 25. Okay, there's just a typo. That's it. Let me check again. Okay, our output matches with the expected output. Now let me submit and see. Yes, all the test cases are passed, and we have an accuracy of 100% and total time taken is just 0.37 seconds. Okay, so that's how we will solve the problem. And that coming to the time complexity, we are looping only once through the array and using a hash map with a constant time operations. So therefore the time complexity will be order of n only, and the space complexity will also be order of n due to the hash map. Okay, so that's it. That's the solution for today. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more coding tutorials. And if you have any questions or suggestions, and if you also have any code more efficient in this, please do put that in the comments and I'll surely check on that. Okay, so thanks for watching guys, and I'll see you in the next video. Keep streaking.